Okay, welcome back. Today our mission is to use the greatest common factor to rewrite expressions before you factor. So here we have 2x squared plus 10x plus 12. Now, something may kind of alarm you. If I were to say, hey, factor this, you may be kind of unaware about that too. We haven't really talked about what happens when there's something in front of the variables. We looked at something in front of the x variable, but never the x squared variable. So what we're going to do is very similar to if you ever had siblings and if one of you has been punished. Maybe somebody is misbehaving with a toy, and then for some reason your parent takes everyone's toy, right? It doesn't necessarily feel fair, but at the time it's just what happened. So this 2x squared is misbehaving with this 2 in front of it. It's abusing its power. So we need to take away something from it, and whatever we do, fair is fair. We have to take away from the 10x and the 12. So what we're going to do is check our factor sheet and see if each coefficient has a common factor. Remove whichever one we feel is the greatest. So let's look at each of these coefficients here. We have 2, we have 10, and we have 12. So we look at the factor sheet. 2 is the factors of 1 and 2. 10 has the factors of 1 and 10, and 2 and 5. And then we'll look at 12, which is 1 and 12, 2 and 6, and 3 and 4. So looking at these, there should be a number that is common amongst all of them. And in fact, there's more than one. So let me circle the common factors. Each one of these has a 1 in it. Okay? Each one also has a 2 in it. So we have to ask ourselves, okay, which number is bigger, 1 or 2? That's hopefully not too hard of a question, but here the answer is 2. So I'm going to remove this 2 from each piece, from each, the 2x squared, 10x, and 12. The question is once I remove a 2, what's left? Well, I remove a 2 from the 2, what's left is just 1. So this is 1x squared, right? Remember that was the x squared piece. What's left from the 10x? Well, if I remove the 2, I'm left with the 5. So 5x. And then what about if I remove a 2 from the 12? I'm left with the 6. And this is a non-x term. That's our constant term. So it's just 6 here. Now from here, this is actually something you could factor, because if you recall, you don't have to write the 1 there. It's kind of extra. But this is something that you could then factor using math, MAF, right? We're looking for things that multiply to 6, but they add to 5. We could then look at our factors of 6. Okay, 1 and 6. Well, 1 plus 6 is 7, and then 2 plus 3 is 5. So our factors are 2 and 3. So when I go ahead and factor this further, I get 2 on the outside. I do have to keep that there. I can rewrite that as x plus 2, x plus 3. So using the greatest common factor, we kind of unlocked a new problem to solve. Factoring this is somewhat nonsense. This is ridiculous. Factoring this is exactly like what we were doing earlier in 2C. So all I had to do, just briefly summarize, was recognize that each one of these, especially because this is not 1, there's something in front of the x squared, each one of these has something in common. They're misbehaving. We have to remove it from all of them. Fair is fair when talking with siblings, right? And then I could rewrite it when everything is removed of its 2.